Hello everyone, I'm Professor Yi Chun-tu in Biomedical Engineering Department at National Cheng Kung Universities. This video is talking about the application of the smart sensing integrated with the digital health and digital medicine. Before we start, I will introduce what is the digital health and digital medicine first. In January 2021, WHO announced a digital health application guide to explain that digital health is integrated into communication technologies, computer science, and database application. Its purpose is to provide a decision system for personal health worker or clinical care. WHO announced Smart Guide for Digital Medicine in February of the same year and divided the digital medicine into 5 stages. This content clearly instructed the definition of moving from initial paper-based to smart digital system and expected a new generation of digital medicine can achieve the precise dynamic medical model and automatically arrange the priorities of clinical decisions through the algorithms. From the above, we can realize that along with the progress of health technologies, can enhance and facilitate the development of digital medicine. Due to the impact of COVID-19 pandemic, everyone is dedicated to health IoT and application of telemedicine, including promoting all citizen health and managing pandemic. As we can see whether digital health or digital medicine, the smart sensor play an important role. Under the trend of digital health and digital medicine, Taiwan earned a recognition for high-quality medical service and national health insurance. It includes international medicine level, reasonable price, and the National Medical Care Institution provide newest technologies and equipment for patients. In addition to complete the medical system, the high level of civil qualities is an important reason as well. Based on this medical advantage in Taiwan, many companies start to arrange digital health and digital medicine, especially when emerging infectious disease occur and a tendency of precision medicine grow. In the future, the medical market will focus on 5 dimensions: intelligence, individualization, automation, normalization, systemization. Furthermore, Taiwan has well fundamental of smart sensing in ICT. It makes Taiwan has excellent industrial competitiveness in trend of digital health competition from the integration progress of digital health and digital medicine. Here are some examples of cross-domain combination in Taiwan industry case between the ICT and digital medicine. Such as quantum computer companies along the Smart Medical Service (QOCA) and Siri Cloud Computing Technique product. This series provides the individual wearable device, smart home care, smart watch, and smart cloud clinical system for medical institutions. This shows that the quantum computer companies already started to produce products related to digital medicine. Not only quantum computer companies, but also the compound electronics company launched the Mark Baby Care product. This product uses the smart sensing technologies with a camera and microphone to recognize different crying faces to analyze their behavior. To provide this data as analysis basic of baby behavior for parents. In addition, it can record a baby growth process through the image, which can completely store digitally. ASUS also uses its own advantage in AI cloud service to launch the Precision Smart Platform (AICS). This platform utilizes computer vision, data analysis, speech recognition, and natural language processing in precision medicine to assist the medical staff in enhancing the quality in an effectiveness and precise way. Also can be further used for clinical research and decision assistance. Recently, Acer launched telemedicine software, Acer Telemed. They take the advantage of communication technologies to provide telemedicine. We believe that this system had a great potential under the post-epidemic era. From the above point of view, Taiwan companies are working hard on digital health and digital medicine, from home care to hospital management. Through the introduction, we clearly understand that we don't need the new sensing technologies for digital health and digital medicine. What we need is the new concept and a novelty integration of sensing technologies according to the actual demand. This is an essential abilities in the futures and innovative talent that Taiwan industry needs and rescue for. So, how do we grasp the new demand for digital health and digital medicine? especially the related clinical issues under the post-epidemic era. In our opinion, in addition to understanding the clinical need, we also have to acquire ability to integrate systems and have to cultivate the fundamental in practice. A biomedical engineering talent who can make the prototype into a clinical product is also a target that we are going to train in this course. The following example is a concept development of the smart assistant hearing device. First, we realize the clinical needs for hearing impaired. They can effectively improve their hearing sensation through hearing aid and artificial cochlea. However, there is a challenge for hearing aid under the multiple voice. What is the worst is the people wearing face masks under the pandemic will make the hearing impaired feel harder to communicate with others because of the clinical need above. It is practical to design a smart assistant hearing device to enhance the target voice. By knowing the clinical need and problems, we will provide related sensors for students and guide them to develop a software interface through drawing the medical electronic circuits and to design a device appearance. Also, to cultivate the student ability to understand the process of design medical prototype and management through the combination of student idea and a clinical need to create the prototype. Next, our team member will share the process of drawing circuits, software interface development, and appearance design. Hello everyone, I'm Wei Xiang Zhou. I will introduce the process of drawing medical circuit in this course. In general, we will choose the component after confirming the development requirement and scenario, and then draw the circuits through matching components. The software I use for drawing the circuits is called Ultimum Designer. This software provides an SCH and PCB environment, so user can design the function and the circuit in schematic diagram in SCH. After that, turn to the PCB environment to put the component in 3D. Due to the medical system must follow regulations like IEC 60601-1, IEC 60601-1.2. So remember to pay attention to detail when you draw circuits. For example, the way you lay out the width of line of manpower and position of the wireless transport component. All the things must follow the regulation. Then process the file conversion to GIBR and send to PCB vendor. When the vendor sends the prototype back, we will do the burn-in test for continuous 24 hours a day to check the function of the circuit is normal. If the outcome is normal, we can start to develop the software interface. Take a smart assistant listening device as an example. We will provide a microphone array module to guide a student to draw the circuits to realize the function of the receiver voice and specific angle. Hello everyone, I'm Zhengbing Xu. I will introduce the process of software interface development in this course. At the beginning of the software interface development, we will discuss the function requirement and scenario and choose the software architecture depending on requirement, like system platform and language for system development. Before I start to compile the software, I would like to plan the software process first to facilitate the follow-up work and communicate with the teammate to make sure the architecture is regulatory compliant ISO 14971 and the concept is correct with the teammate. When I finish the plan, I will start to compile the software. During the process, I separate the requirement function to develop and then compile it. After the software compilation, I will do the functional test, including the affection test in different environment and voice. After efficient confirmed, I will integrate it with the circuits to facilitate the application and development for the device casting. Take the example of the smart assistant hearing device. We guide the student to compile the AI recognition and the control system on the voice model to learn the logics of compiling. Hello everyone, I'm Wen Jingxu. Let me introduce the process of casting device. In general, the functional test and prototype have finished in this phase. I will communicate with the software engineer, hardware engineer, and medical staff for the scenario. Apart from redesigning the software and the hardware, The more important thing is through the scenario to design the architecture of a prototype and follow the availabilities of IEC 60601-1-6. In the beginning, I used the 3D makeup software to build and squeeze out the casting prototype, then communicate optimization with the team member. Once everything is ready, I will send an STL file to the 3D printer and print it out. At the end of the casting design, I must combine every single part and in the prototype application. Take the example of this class. The student can realize the progress of integration and develop the cross-domain abilities. Absolutely. If the prototype can be commercialized and integrated with the ICT industry in Taiwan, I believe that we can create more effective and more competitive assistant hearing device. In fact, this prototype still has a lot of work to do before commercialization, but this is an excellent academic portfolio. In this course, we also introduce the requirement of medical regulation in each phase to make the student have the concept of medical regulation. We hope that will be helpful for them to apply what they have learned to their work in the future.